Okay, now I'd like to refer to the handout that you have, and if you don't have, if you're watching this by the videotape, these handouts are readily available all over campus. I believe they use them in the labs for basic algebra. I believe it's a handout called The Slope of a Line. And if you need a copy, call me at my number at 328 extension number 2249, or at Hunt Club 2345. All right? Now, I'd like to show you about a half a dozen, 6 or 8 different equations. Look at the handout. On the first page of the handout, the first equation says y equals x plus 2. The second equation says y equals 3x plus 2. The third equation says y equals 5x plus 2. The fourth equation says y equals 1/2 x plus 2. Number E, it says y equals negative x plus 2. Number F, y equals negative 3x plus 2. G, it says y equals negative 5x plus 2. And H, it says y equals negative 1/2 x plus 2. I want you to just look at those equations and tell me, what do all those equations have in common? They all start off with what? Y equals. And they all have a plus 2 in it, don't they? They all have 2. All right? And they all have an x. And they have a different number of x. So what's different about each one of these is they have different numbers of x, different coefficients of x, but they have the same constant coefficient, the same number at the end of the equation, 2. All right? Now, what I want you to do is look at each of those graphs and tell me, what do each of those graphs have in common? Let me do just a couple of them. I don't have time to graph all of these up here, but what do all of these things have in common? Here's a very steep graph. Every one of these graphs does what? Right, they're all straight lines, that's right. And every one of these graphs crosses the y-axis at the same point. Did you notice that? 0, 2, 0, 2, 0, 2. Every one of these problems crosses the y-axis at 0, 2. Now let me mention something. This place where it crosses the y-axis is a very special point. It's called the y-intercept. The y-intercept is where the graph crosses the y-axis. Now, if there's a y-intercept, what else do you think there might be in these problems? An x-intercept, right? What do you think the x-intercept would be? Where it crosses the x-axis. So if that's the y-intercept, then this point right here would be the x-intercept, right? Now, I'm not going to talk about x-intercepts right now, but let's talk about y-intercepts on this, because did you notice it crosses at 2 and every equation has a plus 2? There might be something there. What do you think? Now, technically, the y-intercept is where x equals 0. Where the graph crosses the y-axis is where x equals 0. So the y-intercept is where x equals 0. And then you find the value of y where that happens. All right? Now, with those in mind, let's look at the next group of graphs on page 1. I'd like you to look at graphs I, J, K, and L. I, J, K, and L. I, it says y equals x plus 4. And J, it says y equals 3x plus 4. K, it says y equals 1/2 x plus 4. And L, it says y equals negative 3x plus 4. What do these equations all have in common? They all got a y equals and a something x plus 4. The plus 4 is what I'm trying to emphasize here. What do you think each of these graphs is going to look like? Each of these graphs is going to cross the y-axis where? Up 4 units. Up 4 units. In other words, that 4, right here, this 4 is the y-intercept. Okay? And at the bottom of the page, you've got M, N, O, P. And those equations look like this. Number M, it says y equals x minus 4. What's the key number in all of those 4 problems? Negative 4. And where does it cross the y-axis? At negative 4. Okay, now do you have an idea of what we're talking about with the y-intercept? Yes?
But you're talking only if you plug in 0 as the variable, right?
That's right. If you substitute x equals 0 for the variable, then you get y equal 4. You see why that works? If you let x equal 0, you'll get y equal 4. In this case, what if you let x equal 0? Y equal negative 4. All right, now page 2. Page 2. We have a whole bunch of exercises in number 4 that I'd like you to do with me right now. This should be very easy. Number 4, it says y equals 7x plus 2. In the A part, B part, it says y equals negative 7x plus 2. C, it says y equals negative 5x plus 6. What is the y-intercept in A? 2. What's the y-intercept in B? 2. What's the y-intercept in C? 6. Now, if you ever have a mathematician for this, you'll have to put 0, 6, 0, 2, 0, 2 for the y-intercept. These are the y-intercepts because a lot of times we want to emphasize that the y-intercept, x equals 0. Because that's what a y-intercept is all about. Okay? Look at number J, where it says y equals 7 plus 3x. What's the y-intercept? 7. Okay? Number L, what's the y-intercept? Y equals 3x. What's the y-intercept? It's 3x plus what? 0. Yes, 0. So the y-intercept is 0 in number L. All right? So we all know how to find the y-intercept, right? We all know how to find the y-intercept. Now I want to show you the next point, and that's how to find the slope of a line. Okay? The slope of a line. I've got 3 examples here in the middle of page 2, and it says A, y equals 3x plus 2. B, it says y equals 3x plus 4. C, it says y equals 3x minus 2. And D, it says y equals 3x minus 4. Okay? All 4 of these equations, what's common to all 4 of those? They have different y-intercepts, don't they? But they all have a what? 3x. They all have a 3x. I want you to see that. 3x, 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 3x. That's what's common to all of those. Now look at the graphs of those equations. The graphs of those equations are all going the same direction, aren't they? They all have the same steepness. And now let me I've already graphed that one for you once. I think I just did that earlier. Y equals 3x plus 2, but I want to do y equals 3x plus 2 again and show you something. Y equals 3x plus 2. Let's make a table of values and graph it quickly. If x is 0, y is 2. If x is 1, y is 3. If x is 1, y is going to be 3 plus 2 would be 5. If x is 2, then what? 6 plus 2 would be 8. 3 would give you 9 plus 2 is 11. And when I go to graph this, look what happens. When I go to graph these points, if I start with 0, 2, then I go 1, 5. If I go over 1, I go what? Up 5. Now I was already up 2, wasn't I? So if I go over 1 from this point, I go up 3, don't I? Do you see that? I was already up 2, so I'm going to go up 3 more. Now when I go to the next point, it's going to be 2 and 8. Now I'm already up how far?
5.
This is 5. So if I want to go up to 8, I go over 1 and up how many more? 3. And if I want to go from that point to the next point, in other words, this is the point 2 comma 8, and I want to go to 3, 11, what do? I go over 1 and I go up 3. Do you notice that whenever I go over 1, I go up 3? Every time. And that 3 is no coincidence that it's the coefficient of x. So we call that the slope of the line. We call that the slope of a line. So now what I've said is if the problem says y equals 3x plus 2, then the slope of the line, we use m for the slope. M equals the slope, and don't ask me why they use m for slope, because nobody knows why we use m for slope. M is the slope of the line, which is the steepness of the line, and the steepness is the coefficient of x, and in this case it's 3 over 1. It means the rise over the run. Alright? And it's always the coefficient of x when the equation says y equals. Alright? Now, take a look at some problems on the next page, number 6. Page 3, number 6. Page 3, number 6. Page 3, number 6. A, it says y equals 5x plus 2. What's the slope of that line? M equals 5 or 5 over 1. Okay? All right, how about the C part where it says, let's see now, the C part where it says y equals negative 5x. What's the slope? Negative 5. The coefficient of x is the slope. What about the F part? The F part, it says y equals x plus 5 halves. Now, what is assumed to be the coefficient of x? 1, which would be 1 over 1. Okay? So do you see how easy it is to find the slope? I want you to do a few of those. I want you to do number I. Number I, it says y equals negative x plus 3 halves. What's the slope? Negative 1. Is everybody with me on that? Okay? Now, the next, so now you can see it's really easy to find the slope. It's really easy to find the y-intercept, but why would anybody want to do that? That's what I want to show you now. In this last 5 minutes, I want to show you what good this all is. So look on page 4 of the handout. Page 4 of the handout, and I'd like to start with number 10, which says y equals 2/3 x plus 5. Okay? Can you look at that and tell me what is the y-intercept first? Give me the y-intercept. Just by looking at it, 5. And now give me the x and give me the slope. Let's use pink for slope. The slope would be 2/3, okay? So in other words, the y-intercept is 5, and the slope is 2/3. Now I want to show you the fastest way known to man to graph this line. You can graph a line almost with your eyes closed. Watch this. This is really neat. You start by graphing the y-intercept. Can everybody graph the y-intercept? Locate that point on your paper, right there. 5 units up. 1, 2, 3, 4, 5. Right like that, okay? And then what? Now, from this point, I want to draw a slope of 2/3. Now, what does a slope of 2/3 represent? A slope of 2/3, 2 represents rise, and 3 represents run. 2 represents rise, and 3 represents run. So from this point, from the y-intercept, use the y-intercept as your starting point. I want to rise 2. Now how do I rise 2? up to. And then I want to run 3. Run means the horizontal distance. In other words, rise means go up, run means go right and left. How do I know to go right or left?
Negative or positive?
Negative or positive, all right? Which would you go if it's positive?
Right.
To the right.
To the right. 3. 1, 2, 3. And guess what? That's your next point. Did you get that? All right, go up 2 and over 3. All right, yes?
I thought you could not have a negative denominator. So how could you?
You could have a negative denominator. Yeah, you could have a negative denominator. We just usually don't, but you could have a negative denominator. Now, the other thing I want to say is, what if somebody gets this backwards and they say, well, I want to run 3 first. What if we run 3? Then what would that be? From this point, run 3, 1, 2, 3, and then what would you have to do? Up 2, and look what, you come to the same point. So it doesn't matter which way you do it first, does it? Okay?
So, say if the exit or the slope was 5 in itself.
All right, what if this, well, let me get to that. Let me do that one as the next problem. You got a good question. Let me finish this one. What's the line going to look like? Just draw the line between those 2 points and make it go in both directions with an arrow on it. Got that? All right, now, he's asked me a good question that I'd like to do for my next example. What if some problem says y equals 5x plus 3? Okay? Now, what would I need to know first? What is the y-intercept? The y-intercept is what? 3. That's this number. What is the slope? Is 5. Now, the x is not part of the 5. I'm glad somebody said that, because x is not part of the slope. The slope is only the coefficient of x, which would be 5. Now, what is 5 if you're going to talk about a rise and a run? 5 over 1. Okay? Now, can we use this to draw the graph? Okay? X and y. So now, start with the y-intercept, which is what? Up 3. 1, 2, 3. And that's the starting point. The y-intercept is the starting point. Now, from this point, give me the slope of 5 over 1. What does 5 represent? Rise. What does 1 represent? Run. Okay? So I'm going to rise first, which would be what? Rise, how many? From this point, go up 5. 1, 2, 3, 4, 5. And then what? Run 1. And that'll be your next one. I got one more I want to do in this segment of the taping, and that is a problem where there's a negative slope. I want to do number 16, and then we'll stop for a break. Number 16, and let you do some problems. 5 minus 2/3 x. Because I emphasize you can't learn this by watching. You've got to do it. I hope you're doing it with me right now. So what do I need first here? What is the y-intercept? 5. And what is the slope? Negative 2/3. Now what does negative 2/3 mean? It means 2 things. It means negative 2 divided by 3, or it means 2 divided by negative 3. You can do it either way you want to, and it'll be right. But shall we just eliminate this because I'm kind of short on time, and we'll just do this. Negative 2 divided by 3. Now draw the x and y axis. What do we start with? In every problem here, what do we start with? The 5. 1, 2, 3, 4, 5. Now, how are we going to do a rise of negative 2? A rise of negative 2. Now think about that. A rise of negative 2 means down 2 and over 3. 1, 2, 3. There's your point, and there's your line. Just like that. See how easy that is? All right?
Did you ever get a both negative?
Well, if you ever had a negative divided by a negative, what would it be? A positive. So you wouldn't have to deal with it. But it would be okay if you did. It would give you a positive slope. One quick thought, if you ever have a positive slope, it's always going to lean to the right and be like an increasing graph. If you ever have a negative slope, it's always going to lean to the left or be a decreasing graph. Yes?
Is the numerator always going to be the y and the
Yes.
denominator always going to be
The
x?
numerator is always the rise, the distance up or down, and the denominator is always going to be the distance right and left. That is absolutely correct. Okay? Now, I want you to practice some of this on page 5 and 6. We'll take a break after I get a chance to see that you can do this, and then I'll take a look at page 6. One thing I want to really emphasize is everything I've said so far assumes the equation is in the form y equals. Every equation must be y equals. And anything that looks like what we've done today is going to be a straight line. And therefore it only takes a point and a slope, or 2 points, to graph a line, right? 2 points, unless it's not a straight line, which is going to be some later section. And this must be in the form of y equals. If the equation is not in the form y equals, like what if the problem is 4x plus y equals to 8 as it is in number 30, then you can't tell what the slope is by looking at this. We'll have to do something else to it. That's in part 2 of this video. Hang on. All right? All right, I'd like to do a couple of more problems from page 4 of this handout. Now that I've seen that you've had a little bit of question on how to solve some of these. And on page 4, I'd like to do number, which one was it? Number 14? Was that the one?
Yes.
Or
22.
22. No, number 22. Number 22. On page 5, beg your pardon, page 5, it says y equals x minus 4. Now, what are the 2 things that you can tell by just looking at this problem? The 2 things that you can tell. The y-intercept would be what? Negative 4. And what about the slope? The slope is the coefficient of x. And this is like 1x, so that would be a slope of 1 over 1. The rise is 1, and the run is 1. Okay? Any questions on that? All right, so now what I need to do is get my x and y axis, and start with what point?
Negative 4.
Negative 4. So I'm going to go down 4 units. 1, 2, 3, 4. That's my starting point. And now, what about 1 over 1? What does that mean? What does the 1 represent? 1 means rise 1. The numerator number means rise, and the denominator number means run. So that, whoops, that's run, not rum. Sorry about that. All right, so we'll need to rise 1 and run 1. Over 1 and up 1, or over 1 and up 1 this way. And you'll have a line that looks like this, right? Is that simple?
Oh, yeah.
Okay. Now, if this is not simple, then you need to get somebody to help you with it, so it will be simple. This is not difficult. It may seem difficult, but it is not difficult. All right, another example that we had, which one was that someone was looking at? Was it number 20? Anyone else have a number they'd like to have me do on page 5?
Do 20.
Number 20.
29.
Or number 29. Let's do number 20. It says y equals 2/3 x minus 4. So what's the first thing? I need a y-intercept. What's the y-intercept?
Negative 4.
Negative 4. And what is the slope?
2/3.
2/3. And what does 2/3 mean? What does 2 mean? Rise 2. And 3 means run 3. Okay? So when I draw this, then I start with the y-intercept, which is 0, negative 4, and I go down 4 units. 1, 2, 3, 4. Okay? Now what? What's the slope?
Right.
From this point, what do I do? Go up 2, and then I over 3. 1, 2, 3. So it's up 2 and over 3. Or you could say I go over 2 and up 3. I'm sorry, over 3 and up 2. Over 3 and up 2, or up 2 and over 3. That gets you the next point. Okay? And then the graph is connecting those two points. Okay? Any question on that? Let me do one more. I wasn't going to do this, but I know there's going to be a question on this one.
29.
Well, the one I wanted to look at is 27. Number 27. Yeah, number 27. Y equals negative 3/4 x minus 2. First thing I need is the y-intercept. What's the y-intercept?
Negative 2.
Negative 2. All right, now technically, the y-intercept, I might as well get you started thinking about this. The y-intercept is 0, negative 2. Okay? The y-intercept is 0. Remember, what's a y-intercept? What is a y-intercept?
0,
It's
negative 2.
where x equals 0, right? And likewise, what would be an x-intercept? Can you tell me? I haven't even told you what an x-intercept is. If the y-intercept is where x equals 0, what do you think the x-intercept would be? Where y equals 0. Yes, we're going to get to that in just a minute now. All right, so here's this problem, 0, negative 2, and now I want to do the slope. Slope would be what? Negative 3/4. Now you can either write that as negative 3 over 4, or you can write it as 3 over negative 4. I want to do it both ways. Will it make a difference? First, start with the graph of the y-intercept. Where's the y-intercept going to be? 0 and negative 2. Okay? Now what? From this point, we're going to rise negative 3. That means do what? Go down 3. 1, 2, 3, down. Rise negative 3 and run 4. So I go down 3 and over 4. 1, 2, 3, 4. And that's my next point. And this is my line. Okay? Is that right? Okay? Now, here's what I wanted to ask you. What if somebody does the slope this way, using a rise of 3 and a run of negative 4? Now, what would that do? Let's start at the y-intercept again and rise 3. Okay? Rise 3. That means go up 3. 1, 2, 3. And what? Oh, I'm going the wrong way. Am I going the wrong way? I thought this graph was supposed to go down. Now think about this. The rise is up 3, and what's the run?
4.
Negative 4. The run is negative 4, so I have to go left 4. 1, 2, 3, 4. And you see, I'm right on the same line. Now, it doesn't matter whether you graph this point and draw the line, or whether you graph this point and draw the line. It does not matter what points are going the right direction. That's all that matters, do you see? So it doesn't matter whether you have 3 over negative 4 or negative 3 over 4. Okay? Right, now, the main thing I want to do in this session, in the next few minutes, is talk about page 6. Because as I emphasized in the last session, the equation must be in the form y equals in order to be able to tell what the slope is. Now, one of the things that always happens on my exams, and I think probably any math teacher's exams, is, we teach you one thing, and then the next thing you know, you've got a question on the exam that looks like something else. Did you ever have that experience? Well, what if somebody gives you a problem like number 30, this would be on page 6, that says 4x plus y equals to 8. Now, what did we learn a few minutes ago in the first part of this tape? If you ever have an equation in the form y equals mx plus b, what is the y-intercept? Y-intercept equals b. In particular, it's the point 0, comma b, okay? And the slope, m, let's see, m is the slope, right? So if the problem looks like this, you can quickly look at it and tell me the y-intercept and the slope, and you can use that to draw the graph. Isn't that wonderful? Now, somebody gives you a problem that looks like this. This doesn't look like that, does it? This doesn't say y equals. And what's the slope? Somebody's going to say, well, the slope is the coefficient of x, which is m. And the slope is the coefficient of x, which is 4 here, which is wrong. You see, you can't tell what the slope is until you get it y equals. That does not say y equals, does it? What would you have to do to get y equals?